Very good morning, Durga Prasad. Very good morning, all students. I hope you are doing well. Yes, very good morning. Yes, very good morning, Janvi, Sajid, Saisri, Sneha. Very good morning, all students. I hope you have your breakfast and you are in refresh mood. Yes, good morning, Divya, Rajeshwar, Shruti, Tilak. Bhavya, ठीक है, चलो. Okay. So last class we have started which part? Yes, Manish, very good morning. All I'm good. I had my breakfast, yes. Good morning, very good morning. Chalo bhai batao. Last class we have done what? We have done the hybridization concept, their geometries we have discussed. Some examples done as per NCERT, where electronic configuration is given. Where electronic configuration is given. Electronic configuration is given. ठीक है? Any question you want to ask first? Any questions you want to ask in any paragraph or any example you want to ask? Then we'll talk about the VSCPR model, and then VSCPR model with hybridization we will club in the examples. Any questions you want to ask? ठीक है, बोलो. So last class में what we have done? Yes, good morning. Yes, now focus on this part. Last class we have discussed what? Last class we have discussed the steric number. Steric number is basically what? Steric number is, doubt is there. Tell Tarigonda which example doubt is there. Yeah, type fast now. The lag is there. I think you are. Where do we use tetrahedral and planar? I told in the last class that we use sp3 mainly here. dsp2 will be used in coordination compounds. ठीक है ना? In coordination compounds, that time you discuss about strong field ligands, weak field ligands, mainly there. Just like we do na in coordination compound, sp3d2 or d2sp3, sp3d or dsp3. So dsp3, d2sp3, all will be when we talk about the coordination compounds. In this chapter, so we say tetrahedral sp3, trigonal bipyramidal sp3d, octahedral sp3d2. ठीक है? Now, the square planar, another is there, dsp2, another is there in shape, which is different, which is in VSCPR. So stake number 2, 3, 4. ठीक, here in stake number 2, what's the hybridization you have written? SP. And what is the geometry? Electronic geometry means complete. Lone pair plus sigma bonds. Electronic geometry is linear. ठीक है? Bond angle कितना भाई? Bond angle is 180, or you can write it in this manner. Structure you can draw. Suppose this is central atom, other are two sigma bonds formed. It is bond angle 180 degree. ठीक है? Yes. You can message in the group. There you can talk about it. Right now, focus here. SP hybridized, linear geometry, this type of structure, central atom A, attached atoms B. That is bond angle between two atoms, between two bonds, angle is bond angle 180 degree. If it is sp3, you know it is sp2 hybridized. If it is state number 3, 3 hybrid orbitals are used, which one? 1s and 2p. Then it is electronic geometry will be what? Electronic geometry will be trigonal planar. Last class I have written, you can write full form. na, trigonal fill. Now TP I am writing here. Structure will be central atom A and attached with 3 atoms. This is the way to represent. This is the, ठीक है? Bond angle is 120 degree. How many 120 degree bond angles are there? How many 120 degree bond angles are there? How many 120 degree bond angles are there? Very good. 3. Similarly, seg number 4, sp3 hybridized. How many orbitals? 4 orbitals. 1s and 3p, that makes summation 4. Tetrahedral. sp3 is tetrahedral. Structure will be like this: central atom A, attached atom B, and bond angle each. कितना bond angle भाई? 109.5. हाँ, 109 degree 28 minutes. Yes. Now tell me how many 109.5 degree bond angles? How many 109.5 degree bond angles? Out of the students who are responding, Sneha got it correct. Sajid, already I said, you forgot it. That is in only one student is responding right. Second student also there. Can you explain? Sneha and Sranya. It is difficult to explain. I'll explain. Dadi Peta, yes, it is right now. Harshvardhan, right. Vijay, right. Shruti, right. Okay, good. Those who are getting it 6, this is correct. There are 6 109.5 degree bond angles. How? Observe here now. Yeah, those who are getting 6, very good. Suppose I am marking this as first atom. 1, it is second, here it is third, it is fourth, it is fifth. Observe here. I am fixing 1. 1, 2, 3. One bond angle, 1, 2, 3. Other is 1, 2, 4, 1, 2, 5. 3, 109.5. Take next 3, 2, 4, 3, 2, 5. How many? 3 plus 2, 5. Next 4, 2, 5, 6. आई बात समझ में? 1, 2, 3, one angle, 1, 2, 4, 1, 2, 5, 3. Then 3, 2, 4, 3, 2, 5, plus 2, 5, and last one is 4, 2, 5. Other you try, you will get repetition only. ठीक है? Then important is which one? Next one, which is sp3d. That is which one? Trigonal bipyramidal. Full form you will write. I am writing TBP. Structure will be like this: central atom, here attached atoms. And then it is, so in trigonal bipyramidal, 3 atoms in the same plane, 1 atom above the plane, other below the plane. That is trigonal bipyramidal. Adjacent bond angles are 90 and 120 degree. 90 degree and 120 degree. They are which angles? Adjacent bond angles. If you talk about opposite, then 180 degree also possible. Which one? 180 degree also possible. Axial equatorial, in the VSEPR model mainly we talk. Here we are not using in hybridization these terms. ठीक है? Getting it? So here other angle possible is 180 also, which is opposite. And that we can find later on. 90 degree we can find. Next one is 6, which is octahedral sp3d2, which is regular geometry octahedral, electronic geometry octahedral, and if central atom A, 4 atoms in same plane. And all adjacent angles 90 degree. All adjacent 90 degree. Other possibilities 180, yes. If we say these are exactly 180, these are exactly 180. But when you see the NCRT structures, in that what is given mainly adjacent angles are discussed. If total angles are, yes, 180 degree also there. Then take number 7, SP3D3. Last class we have discussed pentagonal bipyramidal. In this case, central atom A, just like pentagon. These are 5 bonds in same plane and one bond above the plane, other below the plane. So here bond angle 72 degree which are in the plane and perpendicular 90 degree. All adjacent bond angles like this. 180 possible, yes, which are opposite. So it's up to you, you mention that one or you can skip that 180 here, because whenever bond angles are mentioned, they are adjacent bond angles are given. Octahedral is a regular geometry or which geometry? Electronic geometry. ठीक है? Getting it? And square planar structure in SP3D2. It is given by normal geometry VSEPR model. By VSEPR model. Yes. So that in hybridization we will not do. In hybridization we will do octahedral. And mainly up to octahedral questions are there. ठीक है? Square planar and tetrahedral, that I said you will discuss square planar and square DSP2 in coordination compound. In class 11th or these examples which we cover, you will not get. Where you will get? In coordination compounds. While ligand case arises, inner orbitals are available due to pairing of electrons. So here in SP tetrahedral we will talk about mainly which one? SP3 and हाँ ठीक है. Now these are the bond angle, regular geometry, electronic geometry there. Other examples which we have discussed in last class, that along with VSEPR, that is our preparation. ठीक है. So now rather writing more example of hybridization, what I will do, I will start VSEPR and all the examples of VSEPR we can solve for the hybridization also together. Because in exam, when you see the questions, they are interchangeably used for VSEPR and hybridization. Okay, so now go through this page number, which is 112 as per this book, or you can check page number 112. Here it is given, the valence shell electron pair repulsion theory. Go through this part fast. पहुंच गए. Now see the theory is given. Lewis concept unable to explain shape of the molecules. Then scientists say name given Sidgwick and Powell. They decided this that. Chalo. After that you underline. Proposed a simple theory. What is the simple theory proposed? That the repulsive interactions of the electron pairs in the valence shell of the atoms. Based on which factor? Based on the repulsive interaction of the electron pairs in valence shell. On that basis, the theory is framed, and that is termed as which theory? Valence shell electron pair repulsion theory. आई बात समझ में? So by Lewis model, we did not talk about the shape of the molecules. Then what is given here? The given part is valence shell electron pair repulsion VSEPR model, in which basis is repulsive interactions of the electron pairs were present in the valence shell of the central atom. Take it is on page number, now it is on page number 113, this line. So that is the basis. That's why name is what? Valence shell electron pair repulsion. That is the name, VSEPR model. There we are considering the repulsive interactions between the valence shell electrons. That electrons may be in the bond or maybe as a non-bonded form. Clear? So underline these parts. Why? Because statement type questions easily can be framed from that. Then scientist names are given, you can mark them. Less important, but still you can read the names also after that. What are the key points? What are the key points of or main postulates of VSEPR model? So either you can add them in the notes after the class, or you can keep them marked here itself, because NCRT also you will read. Every time you will read NCRT also, so that you become very fast in reading NCRT and you will not miss anything. Okay? Now, go through the first point. Go through the first point of VSEPR. First point of VSEPR model. What is given? The shape of the molecule is decided by which factor? Yes, they are basically depending upon number of valence shell electron pairs. Which pairs? Some are bonded pairs, some are non-bonded. What is the meaning of non-bonded electron pairs around central atom? What is the meaning of non-bonded? Very good. Yes, Divya, very good. They are lone pairs. Yes, bonded means which are in bond formation already. Non-bonded electron pairs means which are lone pair electrons on the central atom. आई बात समझ में? So first point is shape of the molecule decided by which one? The electron pairs in the valence shell present of the central atom. They may be in the bond formation, bond pair electrons, or they can also be lone pair electrons. Unpaired we cannot say now always. Paired also there. The point is lone pairs. Then next point. Read that one also. Pair of electrons in the valence shell repel each other. Why? Because electrons are negatively charged. Electrons are negatively charged. So what will happen? Among these valence shell electron pairs, repulsion will take place. That repulsion decides the shape of the molecule. How? You can read third one. These valence shell, the valence shell is taken in. These pairs of electrons tend to occupy such positions in space. How they are arranging themselves in space in such a way they are arranging such that repulsion between them is minimum. Repulsion between the electron pairs minimum and distance between them maximum. Distance between them maximum. That is how they are arranged. Yeah, electron density, electron clouds, सब everything same terms. ठीक है? Getting it? So these valence shell electron pairs tend to occupy which position in space? Such positions where repulsions are minimum, hence distance between them is maximum. Next point, valence shell, how VSEPR is considering. The point is that postulate means what? Their theoretical points. So we should be able to at least identify in exam. If any question is given that among the following which is correct about VSEPR, which is incorrect about VSEPR. So what is given? Valence shell taken as sphere. Valence shell is sphere with electron pairs localized on that sphere such that these electron pairs are at maximum distance. These electron pairs are at maximum distance, similar point like above one. Only thing what they have considered, they have considered valence shell as a sphere. That's it. So it is a postulate. Electron cloud means any possibility, electron density, it may be lone pair, it may be bond pair. ठीक है? Then next point, this is also important postulate. Why? Because this language is slightly difficult. That the multiple bond is treated as if it is a single electron pair. As per VSEPR, multiple bond is treated, understand one thing, they are not saying practically, they are saying as per the theory of VSEPR, we will consider multiple bond as single electron pair. One thing. Second thing, 2 or 3 electron pairs of a multiple bond, they are treated as which one? Single super pair. 2 or 3 electron pairs, we are treating them together as a single super pair. Single super pair. This is postulate. That's what I am focusing on. These are the principles of which one? PSEPR model. So as per this, multiple bond like single electron pair, or 2 or 3 electron pairs like single super pair. ठीक? For example, if I give you structure of this one, CO2. ठीक? So you all know the structure of CO2 like this. With carbon, left side also 2 bonds, right side also 2 bonds. But when I discuss about CO2, I will say it is AB2 type structure. Which type? AB2 type. I will not say 4 bonds are there, AB4. No. Why? Postulate of ACPR that multiple bond is treated like a single electron pair or single entity. As per which model? VSEPR model. Multiple bond को single electron pair treatment we are giving in VSEPR. So we will say it is not AB4, it is still which type molecule? CO2 is AB2 type molecule. ठीक है? Or this is clear, this one? Or we can say here, if this is the example HCN, HCH suppose, chalo. These are electron pairs in bond. These are electron pairs. These are electron pairs in the bond. So here we are 3 are there. है ना? 3 electron pairs in the bond are there. They can be treated as single super pair. They can be treated as what? Single super pair. So we will say in this case HCN molecule. It is also which type? Similar to, we can say it is also similar to which type? AB2 type. It is also which type? AB2 type. That these electron pairs in the bond 2 or 3, they are also treated like single super pair. So key point is you should be able to identify in the exam, this is a postulate of VSEPR. Example you forget, no problem. कोई बात नहीं. But lines when you read several times, anywhere written that this is correct about VCPR or not. So yes, multiple bond treated like single super pair, or that this 2 electron pairs treated like single electron pair. So that statement is important. ठीक है? That is the purpose that you read every line of NCERT. And every time you will read it, not just once. You will every time read it. ठीक है? Single super pair. Example I have given HCN. Here in this multiple bond there are 2 or 3 electron pairs or not? 2 or 3 electron pairs. So these we are treating completely as single super pair. These 3 we are treating as a complete single super pair, which is the postulate of VSEPR model. Multiple bond. आई बात समझ में? So even if you forget it, point is you will not forget that the statement of the particular point. So sometimes it is difficult. That's why I said sometimes difficult to remember for longer period of time. But what you can remember lines if you have read it 100 times. Take next part, next line. When two or more resonance structures can represent a molecule, VSEPR model applicable to any structure. When you can write a resonance structures like which one? Like this one. Suppose I am writing resonating structure here, CO3 minus. ठीक है? In CO3 2 minus, isn't it AB3 type structure? So by VSEPR we can say it is a explanation, it is AB3. If you write it's another resonating structure, other structure will be minus here, double bond minus there. Here also we can say or not, VSEPR model apply, yes. So these are two resonating structures with respect to each other, and we can apply here what? VSEPR model also to any of the structures. Getting it? So these are the postulates which wherever required I explain that one, and you will every time read it, keeping in mind any line coming in statement 1, statement 2, I will clearly mark it. Important point is what now? Important point is this one. Repulsive interactions is what? That you will add separately. In the notes you can mention postulates, then you can mention NCERT page number. Then important is repulsive interactions. Which is strongest? Lone pair, then lone pair, bond pair, and last bond pair repulsions. That is the repulsive interactions of the electrons on the central atom in the valence shell. Lone pair maximum. ठीक है? Reason is what? It is also given there. What is given? Lone pairs are always closer to central atom. That is why they take more space. Hence, more repulsion. Whereas bond pairs are not towards central atom, they are in between the two atoms. They are in bonding form. They are in which way? They are in the bonded form. So which are having more repulsion? Lone pair, which are on the central atom occupying more space as compared to bond pair which are between two nucleuses and they are experiencing more force of attraction. Take. Now here you will underline which part after that? You will underline this part after the repulsion intensity, this part. From this, which question can be easily framed? Assertion, reason. Assertion given, repulsion intensity order, and reason given this line. While lone pairs are localized on the central atom, each bond pair is shared between two atoms. As a result, this, that. Ho gaya. Getting it? So that underlining part is important here. Repulsion intensity order, then reason also. ठीक है? Up to this part clear? Very important it is. After that, you can see these repulsion effects. These repulsion effects what? They affect what? They affect the resultant deviation from the idealized shape. What happens when in VACPR we are talking about the repulsion factors? So what happens due to the lone pair presence? The regular geometries will be distorted. Or what is the term used? Deviation from the idealized shapes and alteration in the bond angles. So due to the repulsion factors, the regular geometries and regular bond angles, they will be distorted or deviated. How much deviated? That we have to learn the particular set of examples. Okay? Getting it? Now, in the notes we will write the which part? In the notes you will mention the VSCPR model. ठीक. In VSCPR underline part already you will go through, then postulates you will not write, or if you want you can write these 5 points, but they are same in NCERT. So you will mention the page number from NCERT every time. Whenever you go for it, you read it. From NCERT it is there. Then important term is repulsion intensity order. रिपल्शन इंटेंसिटी में सबसे ज्यादा लोन पेयर, सेकंड वाला लोन पेयर बॉन्ड पेयर, थर्ड वाला बॉन्ड पेयर. ठीक है. रीजन, लोन पेयर्स आर क्लोजर टू द सेंट्रल एटम and they occupy more space, whereas bond pairs are shared between two atoms. They get more force of attraction of the two nucleuses, hence lone pair repulsion maximum. ठीक. Then here important part is the types, structure types in VSCPR. First is given on the other page, AB2 type. First is the types given here. On page 114 it is given geometry of molecules in which central atom has no lone pairs. So first type is which one for us? First is AB2 type, in which two bond pairs are there. ठीक है, in which two bond pairs. Then we talk about AB3 type. Then in AB3 type we will discuss another types which are given here. ई बात समझ में. So चलो AB2 में central atom A and two bond pairs. ठीक. Already we have done hybridization, it is sp, but here we are discussing from the perspective of repulsions along the electron pairs in the form of bond pair and lone pair. So by using hybridization also we can find the answer in exam. This is the linear geometry, na? It is electronic geometry or linear geometry. Bond angle is 180 degree. Examples are important. What is the example given there? BeCl2. Other example, HgCl2. HgCl2 is purely covalent compound, that we know, and reason can be arising from its high polarizing power of Hg2 plus due to poor shielding of the electrons. BeCl2, HgCl2. Other example, already done CO2. You can say HCN structure. Other examples, NO2 plus, SO2 नहीं आएगा इसमें, NO2 plus etc. Getting it? In your notes you write with more spaces so that you can add more examples when you go through your module. Add more examples. NCERT, add more examples from that. NCERT exemplar, add more examples. Your strength for chemical bonding, you know what? you solve all the questions of VSCPR hybridization. That is your strength. If 4 options given while you are practicing, even if you get the answer from the one, still write down the other 3 structures every time. Because always questions are asked from these structures from this chapter. Always. MOT, very important. VSCPR mixed with hybridization, very important. I3 minus we cannot write in that because lone pairs will come. Getting it, Shanya, Sneha, ICL2 minus, no. It is regular geometry, no lone pair. That is why AB2. Lone pair comes, we have to mention it separately. Next one, AB3. Regular or molecular geometry is this one. It is trigonal planar. Already we have discussed it as per regular geometry in hybridization. Bond angles all 120 degree. Example also you can write. Example, yes, BF3, very good. BF3, BCL3, other examples also there. Return. These all, if you observe, central atom has no lone pair. What is there? There are 3 bond pairs present. Okay. Then any structure you want to write, you can try that structure. Any structure you want to write, NO3 minus also possible. Identify the structure also. Identify the structure. BF3 trigonal planar shape, na? Trigonal planar regular geometry it is, yes. Any structure BF3 you can write directly. Central atom B, F3. Same way BCL3. In hybridization we have done that. sp2 hybridized. Yes. sp2 hybridized. BCl3 is not there. BCl3, yes, same. Or SO3 structure you can write. This is the SO3 structure. How? Sulfur has 6 valence electrons, all in bonding with oxygen. Oxygen, if neutral, form double bond with central atom. CO3 2 minus. LiH3 is not there. LiH is there. Na? LiH3 how? Rakesh, how it is possible? You have to purchase from here. Na? AlCl3 is covalent. AlF3 is ionic. AlF3 is ionic. BH3 basically goes for banana bonding. Here remember, here central atom has no lone pair, so we cannot take H2O or ammonia. Why? They are in lone pairs category. Okay? So that is how you have to remember. AB3 means A with 3 bond pairs, 0 lone pair. That example. आई बात समझ में? A with 3 bond pairs and 0 lone pairs. As per VSCPR, even if multiple bond is there, treated like single super pair. Now tell me, can you remember hybridization we can find for BF3? It will be which one? sp2. It is also 3 sigma bond, no lone pair on sulfur. sp2 only. BS3 we will not take here. It is B2H6 formation. BS3 example not here. SO3 yes. NO3 minus structure. nitrate ion. From which acid? Nitric acid. That will be the structure of NO3 minus. One dative bond. Why I am saying you have to write the structures once or twice, you might find some structures difficult, but when you write several times in exam, you will take fraction of the seconds to solve the question or writing the structure. NO3 important structure, coordinate bond, dative bond, and how many lone pairs on nitrogen left? 0. It is AB3 type, or in hybridization 3 sigma bonds. One dative bond is also here, 1 bond sigma, 2 and 3. Getting it? So here NO3 minus is a sp2 hybridized atom. SO3 AB2 I have given. Here it is sp2 hybridized. Okay. Completed. This is regular geometry. Which regular geometry? It is AB3. Now suppose out of 3 bond pair, 2 bond pairs and 1 lone pair is there. 2 bond pair and 1 lone pair. Then this case is also given here. On this page it is given. There. AB2L type structure, table 4.7. 103, 1 SO2, and you underline this line firstly on 116, sorry. Underline this one. SO2. Bond angle 119.5. Yes. And important is theoretically this, that after this underline. Reason is what? Why the bond angle is deviated? Yes. Getting it? This example is very important along with the bond angle value. That SO2 bond angle is given in the NCERT table. Whatever is given is important. ठीक है? So after this, AB3's third I am writing from AB3. What is derived? AB2L or AB2E type. Means central atom with 2 bond pairs and 1 lone pair. How many? 2 bond pair, 1 lone pair, derived from which regular geometry? Trigonal planar. Structure will be like this. Central atom A, 2 bond pairs earlier as it is, but 1 bond pair replaced with 1 lone pair. This is bond angle here, which is bond between the, angle between the 2 bonds, and this is theta. So regular geometry is having 120, and here theta will be generally less than 120. What is the reason for that? Due to which factor dominating? Lone pair, bond pair repulsions. Greater than which repulsions? Bond pair, bond pair. Already you underlined it. You can mention here also. So it is which type? AB2L type, 1 lone pair and 2 bond pair. You can take ammonia here? No. In ammonia, there are 3 bond pairs and 1 lone pair. It is different category. ठीक है भाई, आई कहानी समझ में? अब देखो, in this case the shape is what given, or bent shape given, V shape or angular shape. All are given in the books, so you can mark any of them. These are the different shape or normal geometry, you can say, but electronic geometry remains same, which is regular geometry. It is trigonal planar, which is regular geometry. ठीक? And normal geometry or shape is bent shape, V shape, angular geometry or angular shape. I hope you are getting it. This is derived from AB3 and it is AB2L type. Examples which are given: SO2 already that you have marked, other structure O3, other structure you can take what? In that one you can say SnCl2 also. That is possible. SO2, O3. Let me check any more example given there. Other example is which given? Any other example of AB2L type? PbCl2 is there, yes. Central atom is there with two bond pair, one lone pair. SO2 हो गया. NO2 minus is there, very good. So these are some examples where, that's why I'm saying you can write with more spaces so that you can add more examples once you are getting anywhere in the module you are solving, add them. O3 structure, it is like this one. Central atom oxygen, other is this one, other is either this way you can mention or normal bond with plus minus. Both are correct. This is AB2L type structure. Same way SnCl2, NO2 minus important structure, N double bond O. Here single bond O minus charge and N has one lone pair. NO3 minus structure you should practice, NO2 minus you can practice important structures. Nitrogen 5 electrons, 2 here, 1 there and 2 there, total 5. Formal charge we can find later on. If you know the concept, then you can apply it. Yes, it is +1 here, it is 0 here, here -1. Yeah, resonance we will use to explain that. Okay, partial bond we can use resonance. Right now focus only on VSEPR, clubbing with the hybridization wherever possible. Take any doubts you have up to AB2L? Up to AB2L type. Any questions? Because in next class I will start AB4. Then complete set will be there in which axial bond, equatorial bonds all will be there. ठीक है, तो do one thing after the class, whenever you start the working on the subject, in 20 minutes try to wind up the class work, reading, learning example. ठीक है, then you start working on the test. You can again start the preparation of the test, but you will not leave because next time when you read it will take more time. So complete it fast. It is in your mind, it will be fresh by that time. Okay, students, done. So let's see how many of you get good marks. I hope you are working and you are motivated also because recently NEET has gone. So I hope that you will get good marks. You are reading line by line. You are reading the definitions also line by line in the NCERT so that nothing you will skip. And remember the VBT curve which we have done first, it is also there. VBT curve of H2 molecule, energy, potential energy diagram, that one, potential energy curve. Informative, keep your proper names also. Name is informative vlogs should be there. Okay, you can talk to the online in the batch. You can ask online WhatsApp batches there. You can mention there. Any student will share. Okay, students, take care. Bye bye. We'll meet in the next class. I'll ask the marks also. Bye bye.